Hello and welcome to Ed School everyone. Today we are going to start with chapter number 1st of class 12th, and that is electric charge and field. So first let's understand that what is electric charge. So electric charge is an intrinsic property of the elementary particle of matter which give rise to electric force. Now let's understand this. So what are the elementary particle? You might not know about the elementary particle word, you might not have heard about it, but fundamental particle everyone has heard. What is the fundamental particle? See, atom. An atom further contains electron, proton and neutron, which are nothing but the fundamental particle. Now in them, electron and the proton are one which contains the charge, electron containing the negative charge and the proton containing the positive charge. I believe this is story everyone know. Now the thing is that these electric charges apply force on each other or between each other. For example, if I have positive and the negative charge, which are considered as the opposite charges, they will apply attractive force on each other. The positive charge will be attracting the negative one and the negative will be attracting the positive one. So there is an attractive force in between them, attractive electric force in between them. While if I bring the similar charges, positive or negative and negative, we see that they have a repulsive force on each other. So this is very important, that it is an intrinsic property of the matter, and second thing is that they apply electric force, right? They give rise to electric force between. So the opposite charge will be having an attractive force while they will be having a repulsive force. Opposite attracts and the similar repel. Okay, let's understand some of the important points regarding charge. So if I talk about the charge, there could be the two types of charge specifically, that is the positive charge and the negative charge. Positive charge being on the proton and negative charge being on the electron. Okay, and what if there is no charge on the body? See, no charge on the body means it is neutral. It does not have any charge. Neutral means everything is made up of electron, proton, neutron, everything is made up of atom. So it's not possible that if a body has no charge, it means it does not have any electron, it does not have any proton. That could not be a scenario. But what could be a scenario is that body contains the equal amount of electron and proton. That body contains the equal amount of electron and proton, and that could be the scenario where there will be no charge on the body. Okay, then I have just written this thing, that opposite charge attract while the similar charge repel, which I have explained you that if there is a positive and the negative charge, they will be attracting, while if there will be the similar charge such as positive or negative, they will be repelling each other. Then charge can be transferred. Suppose that I have two body 1 and 2 over here. This one contains positive 4 charge and this one contains negative 4 charge. Then what can happen, that it contains, first of all, positive 4 means that it is deprived, right? It is deprived. If they deprive of what? Deprive of 4 electron, while this has excess of 4 electron, right? It has it has 4 more electron than it should actually have, right? So 4 electron, it has 4 more electron while this has 4 lesser electron than it should have. Okay, though we were talking about the transfer. So what will happen, these electrons from this negatively charged body will travel to the positive charged body. So we see this thing, that charge can be transferred. The example of this most common is that when you have a balloon and you rub it on your head, like on your hair, right? Then what happens, that it gains the charge, and because of that charge, if you will place it on the wall, it will get stick. Why? Because the charges attract each other. So there will be some charge on the wall, some charge on the balloon, which will attract it up. And how does that charge come up? Because you had rubbed it up. Later on we will be also understanding about the methods of charging. Right now we are just understanding few properties, not properties, some important point regarding charge. Charge is invariant. See, what does that mean? Either the charge is kept at rest or it is moving with a very high speed. No matter what, if it is at rest, if it is moving, every time the value of the charge will remain constant. Every time it will remain same. It's not going to change if it is moving or at rest. The fourth point is that if the charge is at rest, then it has some electric field around it. For example, if there is a positive charge, then there will be certain electric field around it. What is this electric field? This is the area in which the other charge will experience the force. If you will bring the negative charge under this electric field or in this electric field, then it will feel a attractive force. If you will bring the positive charge in this electric field, it will feel a repulsive force. So electric field is the region around which the other charge could be experience of force because of the main charge. Alright, so charge, when it is at rest, it has some electric field, while if the charge is in motion, but it's like a non-accelerated motion, acceleration is 0, in that case it will have electric field, but not only electric field, at that time it will also have magnetic field. There is a whole one chapter in the class 12 that is magnetic field because of the moving charges. We will be understanding about in detail. So remember this thing, that whenever the charge is at rest, it has electric field. When it is in motion, non-accelerated, in that case it has electric field and magnetic field. But if the charge is moving in motion and it is an accelerated motion, the acceleration is changing, in that case it has electric field, it has magnetic field, and also it emits up energy, right? It emits up energy, it gives out the energy, and that is what we say as like it emits out the energy, and that energy it is emitted out na, we say that is EM wave, the electromagnetic wave. So it emits out the energy in the form of EM wave. Charge is a scalar quantity. It means it will not change with the change in direction. Either you take a charge from the south to north, north to south, the value is not going to change. It does not depend on the direction. It's a scalar quantity. And the last thing, it's a dimensional formula is AT. What does that mean? Now you know this thing, that the formula of current is Q by T from the class 10th. We have studied current electricity in the class 10th. From there we know that I is equals to Q by T. Q will be equals to what? I multiply by T. I will take this T from the denominator to the numerator on the other side, and then I got that Q is equals to IT, where the I is what? A, ampere, and where T is what? Time. That is represented by T. Now the unit of it will be what? SI unit is Coulomb, while its CGS unit is ESU. Don't worry guys about these points and all of these things. We will be understanding about in the continue videos as well. In the next video we will be understanding about the properties of the charge and many more. So stay continue. That's it for this video. Bye bye.